Hi, everybody. Thank you. So my name is Michele Leroux Bustamante. I do have a company called Alliance. It's an assembly of various subject matter experts and over 200 partners across our practices. But I run the microservices and security practices. And we do, a fair amount of strategic microservice, work where we help from the business side all the way through to delivery to Amazon and Azure mostly. And we have an identity and access management practice with a team around that topic. So we kind of, in this talk, want to blend the two together a little bit and talk about how we look at API security from a development perspective and a delivery perspective in a microservices solution that has size, okay? So let's start with our hello world today. Pretty much every application you build is going to have, web applications, server-side spas, probably some mobile aspect, backend APIs for all of those. You're going to have third-party API integration, possibly. You're going to have backend APIs that protect your data and give access to the domain. Maybe backend processes, jobs, and so on. And then perhaps an API gateway in the front to standardize how we throttle access, manage access, and even security and token validation. So it's complicated already, right? Right in the hello world space, we're already dealing with, distributed system problems. And so we have to deal with high availability, scale, reliability, resiliency. And that's before we introduce microservices, where we try to introduce, smaller units of manageable work that is possibly also isolating the data backend so that we can have separate, work streams, right, and not interrupt and stomp on each other. But it's a little bit more strategic than that, because in a microservice world, we usually think about dividing your whole solution into domains. And domains are basically, the way we think about it is business capabilities, right? Things that can have their own team, their own boundary around stakeholders and deliverables, and also deployment, lifecycle, and DevOps, right? And so across each microservice domain, you're going to have some backend APIs that, again, control access to the data. Maybe some feature APIs or experience APIs that give you access to specific forms of that data, eventually consistent. And then maybe front-end UI components. And that'll happen across all of the domains that you deliver. And of course, at the end of it, maybe we assemble those things into front-end portals or web application, mobile applications. So we've got, a lot of again, distributed API backend assembling into the front end, right? So this is where we're at. The reason we do it, because there's some pain, right, is because we're looking again for that co-evolution of business capabilities across the organization or solution. We've got stakeholders that are expecting that we can deliver fast. We want to be able to have new features to get new channels of revenue. We want to have new features to solve problems that we're having, maybe even support costs. And we want to do that without being completely paralyzed when we go to hit the button to go to production. And this is a problem we have today with monoliths, for example, typically. You've seen it where you edit 2 lines of code and it takes 2 weeks to get that out to production because nobody really knows all the places that code is used, and they have to go through all the regression testing, if they even have that, right? So this is where we're at today. And again, the goal is that we want to deploy these things at some, improved efficiency. We like to measure that as we deploy these new solutions, right? See how fast we can get the team because of this isolation between the domains. And again, the faster we can ship these new features, the better, right? At the end of it, we're going to have a happy business dance, right? And the goal, again, here is that we're going to have features delivered faster, and we're going to, somehow be able to manage this growing number of APIs. Now, they're going to be more than what you see here, right? A single domain could have 80 APIs. 80 components and moving parts. You're going to have potentially hundreds of these if you have a sizable solution, okay? Depends on the size of your org. But with that, what we're hoping to do is, of course, manage how we secure all of these things. So we're going to talk about API security when we have this large number of growing assets to manage, right? So the first thing we like to think about is, how do we secure APIs? What are we thinking about? We're thinking about APIs that manage user resources sometimes. So, mobile apps, web apps, we log in, we have access to the user, we know who the user is, we can present that to the API, and then we can, control access to resources that that user is allowed to access, right? And then we've got other app resources that back your front end, your back end components or APIs or jobs. They don't care about the user. Maybe it's trusted subsystem for some reason. And so those are two patterns that we might follow. And the idea would be, I log in at the identity provider, right? I somehow now prove authentication. I know who the user is. And I want to present access tokens to these APIs so that I can standardize authentication across all of the APIs with one technique. And that's why the protocols exist, right? So we're going to probably have access tokens in the form of a JOT or JWT. And we're going to present that with knowledge of the user, right? So that would be one type of token. And then the other type of token would be the ones that don't know about who the user is, right? So I just request a token app to app, right? Or some business partner that has a credential to get a token to call. And so the reason I bring this up is also because I think the isolation of those two things is important when you think about standardizing how you authorize access to APIs. APIs that care about the user should always expect a token that knows about the user. APIs that don't care about the user should never need one that knows about the user, and we don't want to mix those things because we don't want to complicate how we manage the code or even API gateway configuration that would handle that, right? So that's a couple of things. So now let's talk about protocol flows that support all of this, right? So first protocol flow that we can talk about is, client credentials. It's simple, right? This would be your backend trusted subsystem type process where I present to my identity provider or token server client ID and secret. I request an access token for the API I want to call. I present that to the API, and that gives me my authorization header. I pass that in the authorization header so that I can validate it. And I'm looking for, did it come from the identity provider I know? Was it tampered with or not, right? Checking the signatures, checking expiry. And then ultimately I'm checking the scope, right? Did that client have the right to call this API? Were they granted a token for this API? Because there's a trust relationship. So with that taken care of, right? I've got, a simple workflow. It doesn't seem that complicated, but we still have to deal with what happens when it expires. So when the token expires, we're going to have potentially, the need to go refresh that token. So I'm going to take the same client credentials, go get a new token, and then present that to the API. Again, not that complicated, but now we have to think about how do we handle the 401 response? How do we handle maybe getting ahead of it with a skew minus 2 minutes, go get a new token ahead of it, right? Maybe I want to cache that token for some period of time. So we're going to rely on middleware or something that's going to validate the token on the server side. We're going to rely on client libraries, hopefully, that will, maybe with our own wrappers on top, automate that dance and handle whatever our business rules are we decided. So I bring this up with a simple flow just to bring up the point, I guess, that obviously this, can have some layers of complexity as we go forward. And what we want is for the developers, if they're involved, to have standard libraries that they can work with across all of these, domains and services and not have to figure out security across each of those teams because not everybody would be an expert and know which flows to choose nor how to handle all of this, right? Now, when we think about, calling and just logging in. So now let's talk about just authentication flows with OpenID Connect. So OpenID Connect, I'm going to make an implicit request. I'm going to get an ID token back, but it's going to be a form post if I'm doing a server-side web app, right? So I'm going to get an authorization response. The browser is going to post that back to my web app, and I'm going to get the ID token. That token doesn't have an expiry I care about, so I bring it up just to point out that that's a 5-minute token. I just need it long enough to establish a session because if it's a server-side web app, it's going to probably have a cookie, right? And the point there being, I still have middleware to do the dance, but I'm not really concerned about expiry and all of that. When we move forward and start talking about SPAs, we have to use a different protocol flow. We used to use implicit, but there were attacks against that flow. So now the recommendation is to use Codeflow with Pixie. And what that means is that my identity provider has to support Pixie, and I need my client to know a little bit about that too. So my flow is going to look like this, right? I'm going to create a dynamic secret, this verifier, code verifier. I'm going to hash it. I'm going to pass that in my request to the authorization endpoint. I'm going to get authenticated as the user. And then my code challenge is stored with the code I get back. Why? Because what we want to prove is that when we go back to the token endpoint, that request came from the same client as the one that initiated the request, right? And so that is how we, circumvent that attack. When we get back our ID token and access token, now of course we're back to API security. So this was the dance we had to do in our SPA so that we could have our access tokens and be able to call the API. So the same thing applies. We need the scope, we need the trust, it needs to not be expired, et cetera. Now, with that, we still want middleware to help us with all of it, right? So middleware or client libraries. So on the client side, the client libraries that we could use, for example, could be the OIDC.js. This is an open source library by Brock Allen, my partner in the security practice, and that handles the whole Codeflow Pixie dance. It handles, loading up an iframe to renew the session silently. It handles, even logging you out if you logged into another browser and created another session at the identity provider. So a lot of good stuff in there to reduce the surface area of what the developer has to know and coordinate with all of these workflows, right? So the message here is Codeflow Pixie, use that for your SPAs, but secondly, there is middleware to help with that process so that we have the standard workflows, right? So all our teams can do the same thing. And then when we think about mobile, it's really the same flow, right? Codeflow Pixie is also what we would use for mobile because we're going to use the system browser. So number one thing comes up with customers here is people want to use native app logins because they think they can do more interesting and engaging interactive login screens and so on. And I've been in situations where it was required by marketing in particular customer situation. And then, of course, the resource owner password flow has attacks against it. They didn't listen, and then they ended up coming back to system browser because they got attacked. So it happens, right? So we're going to use Codeflow with Pixie. We're going to use the system browser, which means you're going to benefit from single sign-on. We're going to benefit from MFA. We're going to have password manager integration and all of the things you'd expect, right? And in addition, it's going to work the same way as I talked about previously, with the exception that there's a communication between the system browser and your app. And then I'm probably going to get an access token back, a refresh token back as well, so that I can do thumbprint, access to the refresh token, and then have that be a way to get new tokens to call the APIs, right? So that's the experience we want. We still need tools to help us do this well. So AppAuth would be the current standard that we're seeing useful for most of our mobile implementations, okay? And again, which protocol flow to use is important, but equally important is, where are the tools and what are the good standards around, building that into your app, making sure you use the system browser, making sure, we're securely storing the refresh tokens in our device storage, which some folks try to invent new storage for that. Not a good idea, okay? Okay, so we got tools we want to make this work easily for everybody the same way, and then we've got good protocol flow hygiene, right? Last thing I want to mention is the protocol flow for, let's say we receive an access token at our top level APIs from the mobile app, from the browser, SPA, and now we want to call a backend API that's available further down the chain, right? That's talking to data. So we never want to use those tokens that came from the browser or the mobile app because that's not a trusted environment when we call the backend. So the whole point would be I would probably do a token exchange. I would get a delegated token that still carries information about the user all the way down, right? And this would be something that, again, each identity provider has a way to support that, right? There are customizations to the extensions to the protocol that support this, okay? And again, we want middleware at the back end for the authorization of the API, and then we want client libraries to help us with the dance because we still have to deal with the caching and expiry and all of that. Typically 10 minutes, 15 minutes for back-end tokens, right? And then even for the front-end tokens in your SPA, maybe a 10-minute expiry, and then it would just constantly renew from within the iframe, right? So we have to think about those things. So all of this plus more, right? We need to think about single sign-on. We need to think about sign-out. We need to think about, again, that holistic picture of session management. And the reason I bring this up now is to say, look, API security is as much about the protocols we use to get the access tokens that we need as it is the actual access token and validation of it, right? and we have to think about the session and how long are these tokens valid, what happens if the user is removed from the system, how do we make sure they're revoked within a period that's acceptable to the security policy of the company. You know, is a 10-minute expiry window okay for a user who's in the browser and has an access token that's still good even though you've removed me from the system? Is 10 minutes okay for me to still have access to that API or not? These are the questions that you have to ask at each tier. And these are the things that you want to put into your policy before you go telling all these domain teams with hundreds of APIs and front ends to, you know, get the tokens, how we should do it. What is our policy? And that should come from the security professionals that can influence it, right? So let's talk about then how we make this manageable, right? So as developers, you know, we are writing a lot of this code using tools we have available, middleware, client libraries, but we still need to understand the protocol flows to make this work, okay? We're gonna have standards-based security tokens, probably JOTs. We're going to be using, you know, OAuth 2 and OpenID Connect, right, for the time being. We're going to have a large number of APIs, so we're going to try to standardize that, and we're going to have all these domain teams that need to share that code, because we don't want to reinvent it across all these different domain teams, because if we do that, then we could run into situations where, you know, they just don't do it right, simply put, right? So this is standard stuff, and it should be the same as much as possible across the board. Pick the flows that matter to your solution. So that being said, that means you have to do some upfront design, gather, right? What is the shape of our solution? Those protocol flows I showed you are maybe the standard ones, but there's always these edge cases, right? I have a hybrid example where we have on-prem and cloud. They still have a cookie and a login page. We have to figure out how to make it work together for now. You know, there's edge cases. So you have to come up with that whole picture so that you can build these tools. And then the middleware and the client libraries to support it, to help the developers doing the work. And then governance, so that you can make sure that you manage all of this across these domains and hundreds of APIs and application parts. So let's talk about the governance, which is the fun part, I think. First of all, we talked about libraries, right? Standard libraries to help you with the protocol dance, but then layering on top of that your security policy, your requirements around session expiry and configuration of that, and the behaviors that you need, right? Same thing goes for the middleware that you might use for authorizing tokens, enforcing scopes, possibly even enforcing that the token had a user identity. And we can even go so far as to say this routes that have a user in the path, that ID has to match the token ID, right? So you can start to come up with these standard practices across the APIs that are common, and then those become easier to implement in shared middleware so that we don't have as many mistakes or concerns around security and access, right? And then that plays into governance, right? So first we have to understand those patterns, then we have to build the middleware to help with it. And that would go for all of these tiers. So another way to look at this, though, is you could have an API gateway in front, right? And that's a very, very popular thing to do, although we still run into lots of situations, even with very large orgs, where they just aren't buying into the API gateway as the solution for all of this, right? So there's the developer approach, right? And then there's, well, taking all these same concepts and applying it at the API gateway level and letting it be part of the infrastructure. So a couple of thoughts about that, right? I mean, I'm passing access tokens from my front end, and I'm calling into my APIs that have potentially middleware that does all this work we just talked about. I still need the client dance, no matter what, to go get the token and handle all of that exchange regardless. My gateway could certainly be the front door to whether or not that token should even be valid. So we have prevention of denial of service as well as before, forwarding requests down to the actual physical components and your clusters. And then, of course, if it's a pass, forward the token down, and we could still validate it at the application itself, right, at the API. We could also exchange it. Sometimes the API gateway will handle the token exchange with your token server, or even from itself issue a JOT or something. So there's a lot of options here, right? You can see. And some of this comes down to the policy of the environment, the customer, the teams involved, right, in making these decisions. I would say one thing that we do run into sometimes is whether or not we should pass that token back from the API gateway or let the gateway be the owner of all of it. And I think if you buy into that, that's actually a great idea, right? But you do have to be very, very certain that those APIs are never going to ever be deployed to a place that doesn't have a gateway in front. And these are concerns for some companies because maybe they don't have a good handle on their automation and delivery process. So these are things you should definitely take under consideration before wiping out how the back end works in terms of your implementation code of the API. The other thing is we still need to know about the user, so that would be an easy way to just forward it along, right? And then I can still standardize around that. Okay. So last point, this is my absolute favorite thing now with very large solutions around microservices, and that is governance of the whole contracts, right? You have all these domain teams and hundreds of APIs, and you need to have standards for how you do routes, and you need to have standards for how you might secure things against the routes. If there's a user ID in the route, then I want to make sure that the token matches that. Things like that come up, right? So what we do is we take OpenAPI 3, right, and we develop contracts, and then the architect team is helping with producing the domain models with the contracts. We produce that with CodeGen. There's open source tools for that, right? The SmartBear tools and the OpenAPI generator, and basically create mustache files to produce .NET code, Java code, drop wizard code, whatever you need. And then at the end of the day, what you're really gaining is the client libraries can include some of the security tickler for each of those APIs, because we can put decoration on the contracts that tell the CodeGen engine what to do with that. And then we can produce host configuration that has secure by default policies. And we can produce API controllers with all the routes laid out exactly so, but also maybe audit ticklers, telemetry ticklers, and also authorization rules that can be standardized. Not everything can be done at the metadata level, but whatever can be, you're going to reduce risk, and you're going to have visibility, and that's good for audit, and that's good for large organizations that need control over that process, maybe for compliance reasons as well. So, putting security into what you CodeGen, taking the time to build this process, is it a little bit of work? Yes, but as they say, no pain, no gain, and that's all I got. Thanks.
All right, and given that it's the last session of the day, we can stay here as long as you want and as long as Michele wants. So I will not be strict with the times as before. Questions? Question?
I guess more of a comment than a question, but I kind of like that you're showing that you can pass the access token back, because I've seen other presentations here and stuff where they're like, oh, just use HTTP headers, but in my organization, you definitely cannot rely upon that backend service not being exposed to other things that can just also inject those HTTP headers.
Yeah.
So like that trust and also I think it's good practice to be honest, where make the app developers at least try, but also have the API gateway in front to double check their work basically.
Right.
And do coarse grain authorization if possible.
That's exactly the people that will do that, right? They're not sure about the controls in place, so it's good to have that second measure. Yeah.
Have you considered, or what approaches have you tried for securing that? Have you tried things like mutual TLS to help enforce that API gateway as the boundary into those backend services?
I mean, honestly, we typically pass the token through when we're using an API gateway for all the reasons just stated. So I think you could make sure somehow these, deployed containers, for example, have to come from a certain path. Maybe, for example, like a WAF. I know that like within the Azure environment, for example, right, we can connect ingress directly to the WAF and guarantee that there's no calls coming in from anywhere outside, right? So if you can do that with your API gateway as well, then that's another way to make sure of it. It's just that now you've got a dependency in the deployment of those containers to say that they're looking for it, which they don't usually know about that, right? They're not usually tied to the deployment environment to that level. So I just think it's worth considering, but it's another moving part now, right? So, yeah.
Question on managing the tokens when you have multiple microservices that have user context. So as there's multiple microservices communicating to each other, and they're managing per user tokens that have been exchanged, do you see any patterns of how to manage that at scale? I mean, there's a large number of tokens that have been
So you're talking
managed.
about when APIs call other APIs,
Yes.
and the fact that we need to do that exchange
Yes.
for another token?
Yep.
And so usually you'll have a caching period, right? Especially for the backend services, you can maybe decide whether or not that's a little bit more liberal if you're seeing scale issues. I wouldn't use reference tokens for that because that would create a very chatty environment at the token server. So we try to avoid that. And then at the end of the day, what you have to do is drill it. So just like if you have a multiple tiered, set of API container calls to complete an action that is not asynchronous, that's stuff that we have to drill, right? Just like we have to drill the containers to see the size, how much memory do they need, right? How much disk space do they use? How much CPU do they use, probably more importantly. And the same thing would go for performance all the way through that thread. So you probably need some telemetry to see if you're needing to adjust your numbers a little bit for the duration for caching and things like that. Yep.
Excellent. One more question also on you mentioned asynchronous. So there's a lot of asynchronous communication that happens between microservices in addition to synchronous. So
Yeah.
Any recommendations on securing those asynchronous, JMS, Kafka, other kind of
Yeah, so
actions?
securing the asynchronous, I think what you're saying is, how do I make sure that when the message is processed, so let's say my writes, if I'm CQRS, are all going through messaging, and then my reads are going direct to some other API, right, for the reading, for the read store. So when I write, I'm writing to Kafka or Event Hub or Kinesis using whatever credentials I need in that cloud, likely, and I'm passing the token in the message as metadata. I could process that token on the other side as part of the metadata when I process the message, but it's not really a token anymore in the sense, you know what I mean? So what we usually do is convert the token into metadata, into the message, so that we know the user all the way down, and we can get end-to-end tracing of web app called API, wrote message, message processed by consumer, called other API, did stuff, and I've got that trail, right, in my logs and audit and diagnostics. But at that point, it's trusted subsystem on the back. So we're no longer validating, was that a user allowed to do that thing? That had to be done above before we wrote the message, typically, right? I know there's always variations of all things, but